Good morning. In today's session, we have to see EMF in a motor, and that EMF will be a back EMF. So we have seen in our previous session about the DC motor and the DC generator. These are nothing but the DC machine, and DC machine is used to convert electrical energy into a mechanical or vice versa. Means what? If there is a DC generator, at that time DC generator will uses the mechanical energy and it will give us the electrical energy. And if there is a DC motor, at that time it will uses the electrical energy and it will produce the mechanical energy. Then we have studied about the equations of the EMF. We know when we are using the DC motor or a DC generator, at that time what we are doing, we are generating a EMF or we are using the DC voltage. हम क्या कर रहे हैं, EMF को प्रोड्यूस कर रहे हैं या फिर हम जो वहां पे EMF है we are using that EMF. So here you can see the equations for the EMF. You can see here, when we are using DC machine as a DC generator, that means what? If we are using the DC generator, at that time when we give the power supply and the mechanical energy, that time in EMF will get induced, and that EMF we can calculate by using this formula. So Z, P, phi, these are nothing but the terms which are we are using by the DC machines constructions. P is nothing but we know when we are making the DC generator or the DC motor, at that time constructions is similar. Only there is difference is what? When we are using the DC motor, at that time it will uses electrical and it will give us the mechanical energy. It means what? Only there is difference in working. And remaining constructions, if you see the DC motor and DC generator, both are same. DC motor, DC generator are consist of stator and rotor. Stator is nothing but we are using some parts that are not rotationary, that are the stationary in the DC motor and the DC generator. We have seen yoke is the outer protective layer which will give the support to assembly of the DC motor and the DC generator. Then we are using the armature. On that we are using the poles on which we are taking the winding. Winding means what? Here we will needed the magnetic flux, because we know there will be the connections between mechanical energy and the electrical energy. क्योंकि DC motor और DC generator है, in which they are doing the conversion of the mechanical to electrical or the vice versa. So here, if P is the number of poles of the DC machine, it is machine DC motor or a DC generator. Flux means flux per pole. If we are having the pole, at that time we are supposed to measure the poles which are introduced in each pole, and we can measure this flux in the Weber unit. Z is nothing but the number of the armature conductor. As we know, when we are using the DC machine or the DC generator, at that time we are taking the armature conductor, because here we need to produce the EMF or we are using the EMF. At that time Z is nothing but the number of armature conductor. Then we have seen about the armature will rotate. So that speed of armature will be measured by using N, and N is nothing but the speed of armature. It will measured in the rotation per minute. T is nothing but the time required to complete the one revolutions of the armature. Then A, we are using their armature winding and that will be in a parallel path. So A is nothing but number of parallel paths in the armature winding. So we can create the equations for EMF by using the flux. Flux is nothing but which will get introduced when there is a concept of magnetic flux. And according to Faraday's law, EMF will get induced. So if you see, Faraday's law will related with electrical energy and the mechanical energy. So Faraday's law is the basic law of the electromagnetism. Means what? there is a concept of electrical energy and the mechanical. So it is the basic law for the electromagnetism, and it will tell us about the interconnections between magnetic field and electric field, which will introduce the EMF. So we will get the EMF equations by using the Faraday's law. If you calculate the EMF, you will get this will be the ratio of fluxes with respect to time, because Faraday's law gives the interconnections between electrical and the mechanical energy. So Faraday law states that current will get induced in the conductor and which will be exposed due to the magnetic field. It means what? If there is a magnetic field, that time current will get introduced, and the direction of current will be decided by using the Fleming right hand rule, which we have explained in our yesterday's session. So we know about the Fleming right hand rule. If we are putting our right hand, in which we are putting our thumb perpendicular with our first finger, if we are putting our thumb upward direction, that time our first finger of our hand will be perpendicular with that thumb and it will be in a forward direction. Again, if you are putting second finger of our right hand, that will be perpendicular with your first finger of the right hand. At that time, Fleming right hand rule states that if you are putting your right hand, in which you are putting your thumb and two fingers perpendicular with each other, at that time your thumb will indicate the directions of the motion of conductor, and here our motion of conductor is nothing but we are using here, instead of conductor we are taking armature as a conductor. So thumb क्या indicate करेगा? It will decide the direction of the armature moving. मतलब armature जो move हो रहा है उसका directions will get decided by the our thumb. That time it will decide direction of our armature conductor, which will be relative with the magnetic flux. And your first finger, which is perpendicular to your thumb, it will decide the direction of magnetic field. And we know if there is a magnet will move in two directions, north or south. So your first finger will decide the direction of the magnetic field, and your second finger of thumb will indicate the direction of induced current. So according to the Faraday's law, we know EMF it get induced and the direction of EMF will be decided by Fleming right hand rule. तो हमें Faraday's law क्या बोलते हैं? Faraday's law states that if there is a magnetic flux, that time current will get introduced. Current will get induced. It means what? Any change in magnetic field of a coil of a wire cause EMF to get induced in this coil, and that EMF we are calling as the EMF in the DC generator. And if there is a concept of DC motor, that time we are calling that EMF as a back EMF, because it will behave opposite with the supply voltage. Because we know when we are using the DC motor, at that time we are using the electrical energy and we are creating the mechanical. So that EMF we are calling as a back EMF, and in today's session we have to see about the back EMF. So we will see what is the necessity of back EMF. So according to Faraday's law, when there is a concept of magnetic field, at that time EMF is get induced and the direction of EMF will be decided according to the Fleming right hand. So Faraday's first law क्या बोलता है? If there is a magnetic flux, at that time EMF will get introduced. And Faraday's second law states that the magnitude of EMF induced in coil is equal to the rate of change of flux with respect to time. So here we will get the equations of the EMF. So here we have seen this N is nothing but the speed of armature, but we are measuring it in minute, but we require time in seconds, so we can convert that minute into second, and here we have do. If there is 1 minute, we can take as a 60 second, and time we can calculate as 60 upon n. और flux क्या है? Flux is nothing but number of pole into the fluxes. So here these are for the one conductor, but we are supposed to derive the EMF for whole our path. So here if we are supposed to derive the EMF for each parallel path, so here what we have to do, we have to firstly derive EMF for one conductor, and then we have to multiply that EMF with how many number of parallel paths. So number of conductors we can calculate as Z upon A, where A is nothing but number of parallel paths and Z is the total number of armature conductor. And we know when we are using the DC motor or the DC generator, at that time on every conductor we are taking the armature winding, and that is in a parallel path. So here we are supposed to derive the number of conductor. We can derive as Z upon A. So you will get the idea about the number of conductors that are connected in series and each parallel path. So you will get EMF equal to EMF in one conductor into the number of conductor connected in series. So you will get E equal to NP phi upon 60 into Z upon A. But this is the EMF introduced. So here we can say the EMF when DC machine will be worked as DC generator and when it will introduce EMF. So that EMF we are calling as the generated EMF. And if DC machine will be working as a DC motor, at that time that EMF will act opposite with the supply voltage. That's why we are calling it is as a back EMF. So here we will see what is the need of back EMF. So what we are saying, when we are placing the conductor in the magnetic field, torque get introduced and torque will rotate the conductor which will cut the magnetic field. And we know when there is a concept of magnetic flux and it will be cut by the conductor, at that time EMF will get introduced, because according to the Fleming right hand, according to the Faraday's law, Fleming right hand rule only giving the direction, but EMF जो introduce हो रहा है वो किसके हिसाब से हो रहा है? According to the Faraday's law. Faraday's law is used for the mechanical and the electrical relation. It means what? It will tell us about the interconnections between the electromechanics. So according to the Faraday's law, when conductor cuts the magnetic flux, EMF will get introduced. And we are deciding the directions according to the Fleming right hand rule. So it is seen that the direction of induced EMF is opposite to the supply voltage that is in the DC motor. These concepts are only for the EMF in DC motor. I have not written here DC machine. यहाँ पे ध्यान रखो. Back EMF will get introduced in the DC motor. This is the type of DC machine. And if there is a DC generator, at that time, these equations are similar. But only what is the difference? Here, that EMF we are calling as the back EMF. And this EMF we are calling as the generated. And back EMF क्यों बोल रहे हैं? Because it is behaving opposite with the supply voltage. So today we will see how it is behaving opposite with the supply voltage. So here we have seen we are calling that EMF as the back EMF, and it will oppose the current which causes it. So here we can see the circuit diagram. If you see, we are having any DC motor. What we are doing here, we are supposed to see what is the use of back EMF. If we are taking one DC motor and we are giving here power supply, E is nothing but the battery. I am giving here supply voltage of a 12 volt. So here we are supposed to see, is there need of the back EMF or not? So how we will get the things? If there is a power loss, and we are not getting any amount of power to work that DC motor which will generate the mechanical work. मतलब हमें क्या करना है? By using the DC motor, we have to convert electrical into the mechanical energy. मतलब हमें इलेक्ट्रिसिटी यूज करना है और मैकेनिकल का कुछ वर्क करना है. But if there is no concept of back EMF, At that time, if there is a no power, there is no voltage, we will get to work mechanical. At that time, what we can say, there is no power, so we cannot do work. And if that power is going for heating, it means what? There will be hot temperature, due to which there are the chances to damage our any particle of that DC motor. So what we can say here, if you see the structure, the circuit diagram for the DC motor, जो हमने DC motor, जो DC machine देखा है, that is nothing but the DC motor. So here I have only taking the symbol for the DC motor, but that DC motor will having yoke, armature, commutator, brushes. So here what we can do, we can give the power supply. We can give the power supply of 12 volt to that DC motor by using the resistance. We are using that resistance to oppose the excess current. So if we are giving here supply voltage of 12 volt and armature resistance that is of 0.1 ohm. So according to Ohm's law, you will get the voltage. So voltage, we are having the value, resistance, we are having the value. So we can calculate the current which is flowing through this DC motor. According to Ohm's law, we know V equal to IR. V is nothing but power supply. So E equal to IR. We are calling here battery as E. So Ohm's law के हिसाब से IR है. If you are converting, rearranging this equation in the form of I, what will your equations become? I equal to E by I. तो हमें E का पता है value. We are taking here 12 ohm. We are taking here resistance 0.1 ohm. So you will get here current equal to 120 ampere. Now we are supposed to calculate the power that will be because of this 12 volt voltage. So we know power is nothing but power equal to E into I. मतलब voltage into current. Voltage का value है 12 volt. Current का value now we have just find out. This is 120 ampere. So 12 into 120, you will get power equal to 1440. And power is having the unit watt. So I have written here W. So if we are giving the power supply of 12 volt to the DC motor, at that time it will generate the power that will be lost in the form of heat, and here heat will be generated that will cause no power left to do mechanical work. So here we will need the back EMF just because of this reason. Because if there is no back EMF, at that time we will not get any amount of power to do mechanical work. So here this is the significance of the back EMF. Sometimes there will be question in exam like explain the significance of back EMF in DC machine. So that is the concept for DC motor. वो DC जनरेटर नहीं रहेगा, DC machine मतलब क्या होगा? DC motor. Because back EMF will get introduced in the DC motor and it will be needed, because if there is no amount of back EMF at that time, power will get lost, it will create the heat and there will no power left to do mechanical work. So here again you see, however, all the voltage is not dropped by the armature winding. So here when armature will start to rotate, we know armature we are using in the DC motor and the DC generator, and it is working as a rotor because it is moving. At that time magnetic flux will get introduced, and as magnetic flux create हो रहा है वो conductor को, when it will get perpendicular with conductor, means when it will cut the conductor, at that time EMF get introduced because of the Faraday's law. Faraday's law tells us if conductor is cut by the magnetic flux, EMF will get introduced. So when armature will rotate, it will introduce the EMF, that is nothing but the voltage, and that will get introduced in the armature winding, but it will opposing and cancelling the part of supply voltage, because we are calling that EMF as the back EMF. It is opposite, it will be in opposite direction with the supply voltage. So here we are saying we are giving the 12 volt supply voltage. We are giving 12 volt supply voltage across the armature. So it will split. It will split the voltage. Some voltage will be given to this armature resistance and some voltage will be given to this DC motor. So accordingly, KVL means Kirchhoff voltage law. Kirchhoff voltage law states that algebraic summation of the potential drop or a voltage for closed loop will be zero. मतलब if there is a supply voltage, if there is a battery, at that time, if you see the summation of the voltage for this loop, that will be zero. And you will take the direction according to the sign convention. So if you calculate total EMF, total voltage, that will be E. E equal to बैक ईएमएफ इनटू वी नो यहाँ का ईएमएफ क्या रहेगा, यहाँ का रेजिस्टेंस दिया है एंड वी कैन कैलकुलेट द वैल्यू ऑफ करंट. तो दैट ईएमएफ विल बी I into RA. We are calling IA because that is the current flowing through the armature winding. So here A is nothing but it is the total supply voltage which we are giving to the DC motor. EB is a back EMF which will be created in the DC motor. RA is the resistance of the armature winding and IA is the current flowing through the armature winding and the DC motor. Because if these are in series, you can see here, these are in series. These are connected one by one. एक के बाद एक connect किया है. So these are in series. So what we can say here, if the elements are connected in series, the current flowing will be same. So that is the current flowing through the armature winding. So here IA is the armature current. If you are calculating the value for the resistance, we are taking it is very small as compared to the supply voltage, because already when I have explained about the circuit diagram, at that time I have told here we are taking the resistance 0.14 and its value is very less in comparison with the supply voltage. So what we are saying here, the resistance of armature winding we are taking very small, so that will create very small drop as compared to the supply voltage. So what we can do, we can neglect that value because resistance का value बहुत कम है. So here the value of voltage will be also very less with compared with the supply voltage. So what we can do, we can neglect that value and we can equate this equation as E equal to EB. Because we are neglecting this term to make our equation simple. So if we are converting these equations in the form of this, what will happen? You can see here. Now what we are saying back EMF is exactly or it will balancing to the supply voltage. When motor will start, if armature is not moving, what will happen? EMF will not get induced because we know when there is a rotation, at that time magnetic flux will cut the conductor. If motor will start and armature is not moving, if armature is not moving, it is becoming stator. At that time we will not get any amount of EMF. So we can take here back EMF equal to 0 volt. And if the armature current is very high, what we are saying here, we are saying the armature resistance is very small. Akshay Kumar, please mute yourself. Please don't disturb the class. आज attendance अच्छा है काफी. Just wait for a minute. Okay. You can see here what we are saying. If motor is starting but armature is not moving, at that time EMF will be 0 and that EMF we are calling as the back EMF, because here we are studying the working of DC motor. So here if what we are saying, practically we are saying the value of resistance is very small of armature winding, due to which the potential drop is very small and we are neglecting. ये term हम neglect कर रहे हैं. But what we are saying, if the value of current is high, ये IA का current ज़्यादा है, at that time what will happen? The initial torque is also very high, because as the armature accelerates, it means what? If the armature will rotate, acceleration will get increases due to the torque, and it will gain the speed and the back EMF will grow. So what we can do, if back EMF will grow, it will increases and current will drop. If current will reduces, torque will also reduce, and it all settles the point where the torque is equal to load. So for a reasonable load and the small armature resistance, back EMF we will needed that will be nearly equal to or approximate with the supply voltage, because if the value of back EMF is 0, at that time what is happening? The value of current will increases. The value of current is increases, and due to which torque will also increase. And as torque will increases, you can see here the armature accelerates due to the torque. Means what? Armature will start to move. Armature will start to move just because of the torque. At that time, rotation speed will increases and back EMF will get introduced, and it will goes to the high value. So just because of these reasons, we will require back EMF that will be equal to nearly with the supply voltage which we are giving. If you see, when we are using the DC machine as a DC generator or a DC motor, what we are saying, armature will be a rotor. It means what? Armature will behave as a conductor and it will rotate, it will carry the current, and that current will lie in the magnetic field of the air gap, because we are putting there air gap to for the cooling purpose. हमने ये सब देखा है. Already we have seen these things in the construction of the DC machine. So what we are saying here, thus each conductor will experience the force, and conductor lie near the surface of armature. That is the common radius from its center. You will understand if I will show the next slide. Just wait for me. You can see here. So you can see here where that armature will move. If this is the armature and it is moving, so we can calculate this distance. That is nothing but the radius. R is nothing but the radius. So what we can say here, the conductor, that is nothing but the armature, will be near the surface of rotor, and we can take it is from the center as a radius. Actually here we have to see the equation for the torque. The torque equation, torque is nothing but it is the multiplication of force and the distance. But how will you get the force? If there is the magnetic flux, at that time what we are saying, EMF is get introduced, and as EMF will get introduced, the rotor will rotate. Rotor is nothing but the armature. जब armature rotate हो रहा है, at that time torque will acting on a body, and it will be defined as it is the force acting on body, and it is the perpendicular distance. This is nothing but the resistance. This is nothing but the radius for that rotation. So here we can calculate torque, that will be the product of force acting on the body and the perpendicular distance of a line of action of force from the axis of armature, axis of the rotation. So here R is nothing but the radius of rotation, radius of that line of action that is rotating just because of the given force, and F is nothing but the force. So here we can calculate force into force into radius into sin theta. इलेक्ट्रॉनिक्स की हूँ ना, इसलिए रेजिस्टेंस ज्यादा आ रहा है मुझे. ओके, you guys can see here we will get the torque equations as F into R into sin theta, and theta is nothing but it is the angle of force with respect to the radius. With respect to the radius, and the radius r is nothing but it is the of perpendicular distance of the line of action of the force from the armature winding. So here we can calculate torque, that will be F into R into sine theta. So torque is the force to cause the rotation of the armature, and it will bring the change in rotation motion, because here when armature winding will rotate, at that time we will get the EMF, back EMF. So here visualize the below shown DC motor front view. If you see the front view of the DC motor, you will find that conductor experience a force and conductor will lie. These are nothing but the conductor. ये the circle का जो outer side है, armature winding. Because we are using here armature as a conductor. So we can say here that armature will experience a force and conductor, that is nothing but the armature, will lie near the surface of rotor of a common radius from its center. We are taking that is as a radius. I have taken here, this is as a radius. And we can say that force will be perpendicular with this radius. So here if you see the radius and here it is the force. So here we can say you will find that each conductor, each armature winding will experience a force and that conductor lie near the surface of rotor. Hence torque is produced across the circumference of this rotor, and rotor will start to rotate, due to which we will get the EMF. So here we can see when DC machine will be working as a DC motor or a DC generator, rotor, this is nothing but the conductor, armature conductor. So we can say armature conductor will carry the current, and this conductor carry the current that will be light in the magnetic field in the air gap. So here each conductor will experiences the force, and this conductor lie near the surface of rotor. From the centers we can take its distance as a radius. Hence torque is produced, and when the machine will operate as a generator, torque is equal to and opposite to that of provided by the prime mover. And when it is that DC machine is working as a DC motor, the torque is transferred to the shaft of rotor and it will drive the mechanical load, because it is converting electrical energy into the mechanical. So at the output it will drive the mechanical load, and the expression for the DC generator and DC motor will be the same. So here the when current carrying conductor is placed in the magnetic field, at that time we are saying force is exerted, and that force will exert in the way that we will get the torque equal to F into R into sine theta. That is nothing but the angle between force and the radius, perpendicular distance. So this torque is proportional to the electromagnetic field. Just because of this reason we are calling that torque as the electromagnetic torque. Some torque which will be proportional to the armature is not fully used as the shaft for doing the useful work, and some will lost due to the mechanical losses. The torque is used for doing the useful work. That time we are calling that torque as the shaft torque. Here you can see when we are using the DC motor and we are giving the here AC supply, अपना power supply, when we are giving, we have already seen these equations. E is nothing but the total supply. We can calculate it is as back EMF into the potential drop across the armature winding. So you can calculate E equal to EB plus IA RA. So by keeping in mind that torque equation of DC motor, we multiply both equations because we needed these equations. हमें ये torque का equation चाहिए. So what we can do, if we are multiplying that equations for both sides by the IA, if we are multiplying equation 2 by IA. What will our equation become? IA into E plus IA into EB, IA into IA RA. I can write IA square into RA. But we know IA square RA is nothing but the power loss, copper loss, because IR is nothing but V, or IA1 is remaining. So we can write this equation as IAE plus IAEB plus IA into VA, क्योंकि IA RA को मैं क्या लिख सकती हूँ, EA या फिर VA लिख सकती हूँ. But we know I into V is nothing but power, so we can take it is as a copper loss. So you can see here the equations. So what we can do here, I can write RA into EB as a power loss. So I have taken here PM. M is nothing but used for the mechanical power. So mechanical power, that the mechanical loss in the DC motor. So we can take PM equal to IA into EB. But we know mechanical power that rotates the armature, that can be given as a torque and speed. This is nothing but T is nothing but torque and W is nothing but angular speed. But we know we can measure that angular, or you can say rotational speed. We can measure omega equal to 2 pi n. Same equations I can write P equal to WT, or omega की जगह we can write 2 pi n. So what I can write here, power loss of, that is nothing but the mechanical power. So we can write mechanical power of the armature winding equal to, we are getting these equations from our circuit diagram. But we know that power is nothing but it is the multiplication of angular speed and the torque. So I can write it is as 2 pi n into torque. But again, if you see our first equation, this is equation. We know from these equations what we can do here, PM equal to PM. तो मैं क्या लिख सकती हूँ इस इक्वेशन को, 2 pi nt equal to IA into EB. You can write. But torque in our EMF equations, we are getting the value of EB or EG. हमें equations पता है. So we can convert that equations in the form of EB का जो equations है, we can convert these equations in the form of IA or a EB, because here we will, when we are equating the equations for power, this is nothing but the power loss. We are taking 2 pi nt equal to IAEB. We can convert these equations in the form of torque. If we are converting, rearranging these equations, your equations will become torque equal to IAEB, as it is A2 pi n, it will go in the dividation. But we are having the equation for back EMF, NP phi into Z upon 60A. We are having this equation. So what we can do, we can put these equations in the form of this, and we are measuring here speed is nothing but Z. We are measuring in the rotation per minute, but we will need it in the rotation per second. That's why I have written here Z upon N upon 60. What I have written here, speed को मैंने फिर से क्या किया है, seconds में convert किया है. If you guys are getting confusions at that time, neglect these things. Directly हमें back EMF का equation क्या मिला था, NP pi upon 60 into Z. So what we can do, we can put these equations in this torque equation. You will get the equations. You can see here. If you are putting these equations, if you are taking the value in the rotation per minute, what we can do, again you can multiply by 60. So your equations will become like this. So here, if you are rearranging these equations, if you are putting the value of back EMF in the torque, your equation will become torque equal to, this is the final equation, purple color में जो दिया है. You will get these equations as torque equal to phi ZP into IA upon 2 pi A. These equations you will be needed to solve numerical, which you will be asked in the exam. And 1 upon 2 pi, that value will be 0.159. So you can take as it is, T equal to 0.159 into phi ZP IA upon A. 1 upon 2 pi का मैंने direct value लिखा है. Or you can convert these equations in the form of torque equal to K into phi IA, and K is nothing but This is Z into P upon 2 pi A. You can call this as a constant term. So this is the torque equation for the DC motor. You will be needed these equations to solve the numericals. If anyone is facing any issue, you can ask me. We will again revise torque equation in our next session. Now I'm taking your attendance. Okay. You all supposed to submit the assignment. I have not get any assignment from anyone. मुझे अभी तक किसी का भी असाइनमेंट नहीं मिला है, तो you guys are supposed to submit that assignment. Okay.
What we have to do in that assignment? What we have to do in that assignment?
I have given the question. You are supposed to write the answers.
And forward it to you.
What?